Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Roohif Part 6.
The Bilby Tower article that you pasted from Wikipedia, and I think the other article was on the Mirror Flash maybe, but I was wondering if you could send me some more information. You had mentioned the 192 kilometer, 118 mile, we'll call it a survey observation. Do you have a citation or an article that goes into more detail of that actual event? Because it was just a Wikipedia article about what a Bilby Tower is and the origin and things like that. So I did look at it. I don't want you to think I didn't look at it, but it just didn't seem to have any of the data I was hoping to kind of look at and try to figure out. You know what I mean?
So there's a stack of like geodetic surveying, triangulation surveys on the NGS NOAA website.
Mm-hmm.
Let me just find it.
If you have it handy, shoot me a link. If not, it's no big deal. I just thought maybe you had that at the ready already. Yeah.
Yeah, I've got it.
And then I looked at, one of the things they mentioned, I was curious what you thought about this. They mentioned that the actual transcontinental transverse, the TCT, was conducted, I want to say like 61 to 76, and they used geodimeters and not theodolite. Or is that a type of theodolite?
I don't know what that is.
Yeah, it was in the Wikipedia article that you sent there. So I think it sounded almost like the electronic version of a theodolite, like it had an electronic readout or something too. And they called it a geodimeter, which it was essentially I'll call it an acronym, but it was more like an amalgamation of 3 different words. Anyways, yeah, I was curious about that.
Oh, so that's a distance measuring. The geometer is the first optical electronic distance meter surveying instrument. Okay, so that wouldn't be good over any more than a couple of kilometers, I would imagine. But yeah, they exist. They're built into total stations now. So total stations have the theodolite part, which just measures angles. And they also have something called EDM, so electronic distance measurement.
EDM, okay, yeah.
EDM, yeah. So look up EDM.
Electronic dance music. Got it. I'll look it up.
EDM. Yeah, look up EDM total station or something like that.
But yeah, if you have any, I'm curious about that actual, you had mentioned, I had asked in the chat last night, you had said they were on mountains. Okay, cool. I just want to know, kind of which mountains were they on, what was the distance, and just do some calculations based on that. So
yeah, I'll give you the link to that library. Oh, there we go.
Why does the meme that you post on that say that it's 180? The angles are 180.
180 and 45 arc seconds.
Yeah.
I'll post that again, one sec. There you go. This one?
I thought you said that the internal angles don't measure 180.
Right. 180 and 45 arc seconds. And more than 180.
What's that? Without the arc second part, what is that? Degrees.
Sorry, without the arc seconds, 180. We could round it to 180 and 1 arc minute.
What's the arc second mean?
So there are 60 arc minutes in a degree, and then 60 arc seconds in an arc minute. Each arc second is 1/3600th of a degree.
what you just posted there, Roof, is that for me or for Timbo?
T-Dub? That's not Timbo, is it?
Oh, is it not? Sorry.
Wonderful. Nice one.
They all sound the same.
Oh,
But what you just posted, was that for me, Roohif?
No, I've DM'd. I DM'd my meme to you.
Okay, perfect. Thanks. Appreciate you. Is it not Timbo? Who's talking about the arc seconds?
It's me, T-Dub.
Edom. Okay, wow. Okay. I apologize. My voice recognition awareness is off.
That's all good. That's the extra 4 seconds.
Oops. That was,
Seconds.
45. Yep.
45 arc seconds. Right. Is that what you're claiming is the excess?
Yes.
Right. How do they measure that exactly? I mean, like, do they like have lasers meeting it, at a point, and then they put a protractor on it, or how are they getting the angles, measuring
With a
that angle?
theodolite. With a massive theodolite.
Yeah, what's the process involved? What?
Like, how does a theodolite work? They have massive metal discs gradiated really finely. So there's a big. I'll send you a photo. One sec. Stick a photo in the chat.
So they did this with lights, right? Did they? They were like looking at lights on other mountains. So they're looking at one light, like through the light. They're looking at a light, and then it's got like an instrument on it, and they turn it to the other light till they see it, and they stop, and then and they can see. We've marked where it was on the protractor sort of thing, and then they second station, and they get the angle.
Yep, they're just measuring an angle between 2 points. So I posted a picture of the massive theodolite they used in one of those things. So the metal plate, the metal circular plate underneath, not underneath. Can you see those micrometers? There's a black metal disc, which you can see there, sort of a third of the way up. That's the plate that they read the angles off. That is a foot in diameter. So these are huge theodolites with massive telescopes. They're very accurate, down to about an arc second. Yeah, that's it. Theodolites these days are much smaller because these ones took, several people to carry and set up. So the ones these days, for convenience, are less accurate.
Hey, Roohif, yesterday, and maybe I'm phrasing this wrong, so correct me if I'm wrong. Yesterday you mentioned that because, and look, this might be a difference. You might have been talking about the measurements you took with the theodolite, different than this specific experiment or measurement we're talking about, not experiment. But you had mentioned that refraction is not, quote unquote, in play because they're horizontal angles or whatever. And so, but if I'm at a distance of 118 miles or 192 kilometers, whether or not I'm measuring horizontally, especially if I'm at elevation, isn't refraction just inevitably going to be part of the equation at some point? I just don't understand that.
Yeah, not horizontally, right? So the refraction happens because there's a vertical gradient, right? So the density changes are vertical. So it's more dense at the surface, less dense higher up. If you look through that density gradient, light will bend, usually downwards, right? So it will curve down, but it won't deviate left to right. So yeah, horizontal refraction is almost never a thing.
Yeah, but I'm also you're saying we're on mountains, so I'm not like it's not like I'm at level, so I am I am vertical per se, or is that a stupid point? I don't know.
Yeah, so refraction, because because the density gradient is in the vertical direction, it either lifts objects up or lowers them. It doesn't move them side to side. There's no very rarely will you see some sort of horizontal gradient that will move the light left or right. That's fairly in specific conditions that can happen.
And so again, if you can, yeah, no, I appreciate it, first of all. And so in this situation, or in this demonstration, this survey measurement, I'm moving a light side to side to get the other point on the other mountain to be able to capture said light. Is that correct?
Yeah, so each point on this triangle has a tower, and at the top of the tower is a light, and every point on that triangle is just measuring the angle between the other two lights that they can see.
And I haven't looked at, I can't see the details of what you sent me yet. Are they trying to be equal in elevation, these 3 points? Are they attempting that? No? Okay.
I just need to see it. Yeah, so they're only measuring horizontal angles. I think they did do some
Well, hang on. Sorry to be pedantic. If I'm not equidistant, or excuse me, if I'm not equal in elevation from point A to point B, then there is a vertical element in my horizontal triangle, though, isn't there?
No.
Well, if
it doesn't matter.
If I'm
doesn't matter what the vertical angle
below
is.
them, but for the refraction point, if I'm 500 meters below them, wouldn't that be 500 meters in vertical elevation difference? Hence refraction.
Yeah, but it doesn't matter. Like it'll be shifted up or down. We're measuring the left to right angle. It doesn't matter what the vertical angle is.
Okay.
Left to right refraction was just what?
Basically, yeah. It only happens in pretty specific and unusual circumstances. Yeah.
They can't confirm. They can't confirm that there wasn't any.
I think they could have. It would have varied some of their results between sort of. Yeah. Not sure whether they mentioned it in the article I'm familiar with.
Would have had to have measured the medium between the points, right? Continuously at specific points. Oh, just many points, like, a few meters, measure it, then go a few meters again, measure it again.
No.
How are they going to do that continuously since the air's, since the air and, the medium is in a constant state of flux?
Right. Yes, but the flux is in the vertical direction. Everything, let's say you have a pressure differential from left to right, guess what happens? It equalizes with wind. Right? That's what wind is pressure equalizing. Yeah, the gradient, if you're looking from mountain to mountain, right, the gradient is very stable. The places where you get sideways refraction, the two examples they usually give are, like, if you're looking along the face of a cliff, like you might have some heat exchange from the cliff face after a long hot day. Same with, like, shooting along the length of a river, you might have some heat exchange between the river and the surrounding terrain. But yeah, if you're looking through air that's well above the surface, it's really stable. So yeah, I think they ignored it in most of these, But there have been studies on horizontal refraction, and it's pretty rare, and it's less than an arc second anyway. So tiny. Simon Dickwad Rumpus Res Eater Dick Roohif is just another ball-tard clown. Thanks, Coffee. Fantastic.
Roohif, how big was this triangle that you posted the screenshot for in the chat?
One of the sides was 192 kilometers, I think. Hang on, one sec.
So
Roohif, have you been able to quantify anything that you've been saying about should have, could have, would have, all that stuff, like the horizontal and vertical gradient?
Yes, with the vertical, and I'll find that study about the horizontal, and I'll be back in a couple minutes.
So Roohif, this triangle was this big, and they only measured 180 degrees and 45 arc seconds, which is literally 0.01% of a degree over 180.
Yeah, aren't they supposed to be
So that
arguing
doesn't
for
match
like?
the globe at all, dude.
Yeah, aren't they supposed to be arguing for a 270 degree?
Nah, like they say the spherical triangles are bigger than 180, but usually they're done with real small triangles when they do the arc of the parallel and whatnot. So, you wouldn't expect to be a ton, even if it was there, right? But with the bigger triangles, it's even worse because you can clearly see that with 45 arc seconds, which is 0.01% of a degree, that is nowhere near the excess that they would need. But because it's there, it's a globe, right? Yeah.
So what gives them the right to call it spherical excess? How have they eliminated other like variables, other error margins of error?
Yeah, no, they haven't. They don't even like that triangle right there, totaling over 180, isn't even the spherical axis that they're talking about in the arc of the parallel. They added in afterwards. I heard Roohif last night saying that they don't do it. Yeah, they do. I'll show you in the PDF. I will post the pages on the PDF right now for you. They absolutely do it after. Jesus, they compare it to the Clark and Bessel spheroid.
Right. I agree.
What are they called?
Spheroids,
and they have yes, and they have a literal spherical excess formula that they use to calculate it and put it in.
Right.
And
they
have
put
to
it
use
in.
an exact. Yes, they do. And they have to use an exaggerated formula for the bigger triangles. I will show you in a moment. I got to find them.
They calculate their expectation. They don't add it to their measurements.
I didn't say they add it to the measurements. They do their measurements. They do adjustments to their measurements, right? But that measurement there of that triangle being 180 degrees almost exactly is basically all of the measurements of the triangles. None of them have the spherical excess that is indicative of the arc of the parallel. It is all added in after the fact, and I will show you the pages that say.
It's not added in.
Dude, are you playing semantics because I'm saying added in? It's calculated. Yes. It's calculated, Roohif, and put in as like an adjustment so that it can look like a sphere. Yes, it is.
Incorrect. They make raw measurements, right? They add up to more than 180 degrees.
No, they don't.
Also, yes, they do. They also calculate what it should be.
Exactly to 180. They're almost all identical. They add in the sphericity afterwards. I was
They don't. They calculate what it should be. They calculate what it should be, and they compare it to their actual measurements, and those actual measurements have spherical excess.
They don't, Roohif. You didn't read it, obviously. It's a 900-page PDF. I've been through it, like almost all of it at this point.
Yep. Matches that measurement matches the predictive model exactly to the T.
Not exactly. Not exactly.
Not exactly. Right.
Not exactly. There are always errors in measurements.
So what do they do? What do they do to account for the error?
Right. Do you understand that all measurements have a margin of error? All measurements.
What do they do to account for the margin of error? What do they do?
Hang on. You're saying, I agree there are errors in measurements, right? Are you saying that they adjust them to include spherical excess?
What gives them the right to call it spherical excess to begin with?
That's
what they know it's not an error.
Okay, it's not an error.
So begging the question.
No.
So this is.
They know it's
So
a sphere.
you're presenting. No, you're supposed to be presenting this thing as a proof of measurement of curvature to prove that we live on a sphere.
Right.
At best, it's angular excess. You can't call what?
Okay.
Why did you presuppose
We can call
sphere?
it okay, we'll call it angular excess if you like.
Hold on. I was talking, but you presuppose sphere in there. You said triangle. You're using triangle with that, and you're also saying is a sphere in the first place. There would be angular excess, whatever the hell that means. It would be error because you can't have an angle triangles more than 180 degrees. Period.
So we'll call it angular excess if you like. That's fine. I don't care.
That's so obtuse. That's so obtuse.
The ordinary formula for spherical excess must be extended to meet the demands of the gray triangles from Pikes Peak to Sierra Nevada. The laws of refraction applicable to lower and equal elevations require modification when great inequalities exist in the height of the stations. Calculation of geographic positions enters a new phase when lines of sight 182 miles long are to be dealt with. The adjustment of the triangulation, that refined operation by means of which incongruent observations are made to blend harmoniously according to the mathematical theory of probabilities, assumes greater significance in a chain of 2,600 miles of continuous geometrical figures.
Okay. Can you post it instead of reading it so I can read it?
Yeah, because it sounded like it said based on elevation difference that you would need to account for refraction. That's what I heard.
Vertically, yes.
And then page 51,
based on
leveling.
Page 51, the computation of the spherical excess of the triangles for all the parts
page 51 of what?
Of the arc of the parallel PDF.
Okay. Can you link that so I don't have to go searching for it?
Sure.
Were they using 7/6R?
They would have been using something similar to it, yeah.
And that's begging the question. They've already assumed that the light is conforming to a sphere. I mean, come on,
so
man.
I'll say no then. They were using something like a density gradient of negative 0.000022. Is that better?
They're always taking whatever they get, though, onto this GS 1984 model. That's what they're doing with it. That's what their adjustments are. And you don't, anyway, by the way, Roohif, you don't celestial navigate with a theodolite. Sorry.
You can celestially navigate with a theodolite.
No, you won't.
You can do that process with a theodolite.
No. Show me anyone in the logbooks where they're using that device.
They're not on a fucking boat, Sonny. You don't use a theodolite on a boat.
See what I told you, folks? Yes, that's what I mean.
Do you understand
Sorry.
The process of celestial navigation?
I didn't want to interrupt your previous conversation. Go on. But see, folks, what I mean?
The process of celestial navigation is taking angles to stars and working out your position. You can take angles. I haven't finished yet. You can take angles to stars with a theodolite, correct? Can you take angles to stars with a theodolite?
No, I just want to point something out real briefly, and it was pointed out quite well. And so I'm not interrupting the previous conversation. I'm out. So carry on with your previous conversation.
Okay. Well, first of all, yes, you can take angles to stars with theodolites, and yes, you can work out your position without being on a boat.
Why the fuck does he keep going when I said I'm done? Okay, so show us the fucking logbooks where they're doing it with the theodolite.
They don't do it on boats, Sonny. I explained the process of celestial navigation.
Show me the
process of celestial navigation is taking angles to three stars and working out your position. I can do that on the ground. Thank you.
We need the logbooks.
Okay, the process of celestial navigation is taking angles to stars and then working out your position. That does not require
logbooks of actuality. The logbooks that actually where they did it in actuality wrote down they're using this equipment. Please, the logbooks, the white papers. Thank you. The data.
Okay. That does not require you to be on a boat to take angles to stars.
Shut the fuck up, then. Don't talk to me about it again. You're a fumbling idiot. You sound like a numpty dipshit.
Okay.
I mean, I suppose I could use a power drill to open my pop can. But it's probably not wise. You know what I mean?
Yeah. I'll say a sextant is a poor man's theodolite. You only use a sextant because you're on a boat.
Show me the nautical theodolite then. Yeah. Ding dong.
Okay, yeah, bubble sextant. There you go.
Last time you were going to Sticks and Shadows and then to navigating. So I still want the nautical Sticks and Shadow kit with Plumb Bob. That's what you claimed. Thank you.
Okay. Sorry, what page am I on? Who was it?
51, I think, is what he said.
51. Computation of spherical axis triangles. All right, give me a second.
Not to mention that they use the least square method to curve the results as well, like the actual initial measurements. And there's so many adjustments, I can't even. Literally, I've read this thing so many times, and I still can't figure out the exact order that they put these adjustments in.
The least squares to curve something? What does that even mean?
Yeah, the least square method. It takes lines, points of like different points on a graph, and if you apply the least square method to it, it'll literally curve the straight line.
I'll read what you're talking about.
While he's reading that, Sonny, if it means anything to you, I'd much rather be caught in the middle of the ocean with you and a sextant than with Roohif and a theodolite.
Yeah, obviously. You can't use a theodolite on a boat, obviously.
How do you level a theodolite on a ship, on a boat when it's moving?
You don't. I'm not on a ship.
You can't use one on a boat.
Correct. Can I take angles to stars with a theodolite? On the ground. On the ground. I'm on the ground. Can I take angles to stars with a theodolite? Yes or no? No one seems to be willing to answer because I think they know the answer is yes. Of course you can.
Roofy, are you okay?
Yeah.
Bullshit. You still haven't shown where anybody in reality fucking does it in the way that you're saying. See what I mean? Everybody hears this.
Yeah,
I almost died.
Don't need to be on a boat.
You have cloaking or something. Sasha, it's okay. This is actually a continuation of a previous conversation. Please don't butt in. If he wants to continue rattling on, I'm going to continue on because it's my freaking argument with him.
Okay. Do you need to be on a boat
try to help it along?
Navigation?
If I get involved, then I'm just going to fucking continue it until it's over. And Roohif doesn't have any reply or answer or direct documentation evidence of anyone in history, I don't care when, going all the way back to however far back he wants to go, that in actuality, reality, someone's out in the ocean doing this the way he says. And all you have to do is go back in the live stream for his method. He points out how he thinks that people are actually doing this. He doesn't have any freaking evidence, Your Honor, of this. It's hearsay only.
Do I need to be on a boat to measure angles to stars?
Hearsay thrown out on his face. Thanks. It was already determined to be hearsay. Thank you very much.
Do I need to be on a boat?
He has no documentation or evidence, Your Honor. He's trying to make a claim with no evidence, Your Honor. It's thrown out of this court. No jurisdiction.
Do I need to be on a boat?
No evidence.
To measure angles to stars.
No evidence.
Do I need to be on a boat to measure angles to stars?
Bring me evidence for your claim, bro.
Just answer the question. Why can't you answer a very simple yes or no question? Of course you're not going to.
The fucking question that I put on is still on the table. You're not going to switch it around. Burden of proof, switch fallacy, whatever the fuck.
Okay, what's your question,
you're not doing that to me. No, I have the question. You haven't answered it yet. That's why I'm still here demanding that you answer the question. Show me the documentation. Shut up. Show me the documentation where anyone in history does it the way you say. I want the citation and the source, the evidence.
Okay, the process of celestial navigation is measuring angles.
Throw this guy on court for insubordination.
You asked a question and you don't want to listen to the answer. Do you want an answer?
Cap fitting as soon as possible. ASAP, stat, dunce cap for this guy.
Okay, do you want an answer to your question?
No,
you want an answer to your question?
You're an absolute moron. You're an idiot.
Do you want an answer? Do you want an answer to your question?
I'm not answering your questions. Yeah, I want.
You want an answer to your question? Okay.
Yes. No,
So I
I
will
don't
answer your question.
I don't want to answer. I want the evidence.
Okay. Right. So the process of celestial
Do you
navigation.
have the evidence?
The process of
Do you
celestial
have
navigation.
the evidence? I know what the
I'm
process
giving
is.
it to you,
I don't
Sonny.
need you to
Shut the
repeat the
fuck up.
process to me. Shut the fuck up. I want the
Right.
evidence. Do you have the? Listen.
Yes.
My last
Listen
question
to it. Are you ready for it? Are you going to listen to the evidence?
I'm going to mute you. Don't shut up.
Oh,
he needs to be muted.
If you mute me and I'll just go. You don't get the evidence.
To you, my last question to you, if you let me finish, do you have the evidence?
If you let me finish, is that a joke?
Yes or no? Why are you fucking talking? The evidence, yes or no?
Yes. Are you ready for it?
Bring it. Show it in the live stream voice text right this fucking minute.
Okay. So you have to listen to the evidence.
Right now. No, not so. Right this fucking minute. Where is it?
Right. Okay. Are you ready? Okay.
Put it in the live stream. Don't fucking talk to me.
The process of celestial navigation. I'm giving you the evidence, Sonny.
No.
I'm giving you the evidence, Sonny.
You're done.
Okay, I don't think we're getting anywhere. Maybe we'll move on back to the theodolite conversation, guys.
Done. If he doesn't bring the evidence next time he speaks, I don't care if someone unserver mutants and undeafens him while I'm here. I don't care. But if he speaks and he doesn't have the evidence in the live stream at that fucking second, I'm going to ban him. Thank you very much. I'll ban his ass. I'll perma ban him. If I can't do it, I'll have someone else do it. Thank you.
Yeah, I think he's gone.
Okay, he's gone. Good. I'm gonna fucking ban him.
I think so. Yeah.
Yeah, I'm gonna ban his ass.
Tags! What is your profession?
See, old friend, I brought more soldiers than you did.